enqueue operation in a circular queue. Okay. So before we are going to see the algorithm, so I want to tell you uh, one example here. So this is what the example which is given here. The array position it is 0 to 7. So here the n value it is 8. N value it is 8. It is represented as a array position, and for sake of understanding I am writing the same here as a circular queue. So inside the memory this representation is not represented like this, it is represented in the sequential order only, but the treatment is circular queue treatment. Okay, so just you understand this concept. And before I am coming to this particular algorithm, so I want to tell you about modulo operator. Modulo operator. What is modulo operator means? Suppose there are two operators as far as the division. There are division and modulo operators are there. So this is we call it as division operator. This is we call it as modulo operator. So division operators, it divides two numbers. It divides one number with another number, and modulo operator also do the same thing. But what the modulo operator gives means, the modulo operator gives the remainder, whereas the divide operator gives the quotient. Okay. For example, suppose I want to just divide 5 divide 8, division 8. 5 division 8 means, what is the value, resultant value? It is 8 is a bigger number, 5 is a smaller number. So that's why the result is in a fraction. So what is it? 0.6. It is 48. Then 2, 20 means 6, 2 like this. Okay, so this is the result of division operator. What about modulo operator with the same value? 5 modulo 8 means, what is the value it is? Value it is 5. It gives the, whenever it reaches the nth term, the same value it is given as a result. For example, 6 modulo 8 means result is 6. When the value it comes to some other value, suppose 8 modulo 8 means, what is it? It gives the result of 0. It gives the remainder. So 8 divided by 8 means it is exactly 8 divided by 8 one time. So that's why remainder is 0. Whereas before that, what is the value? The value is lesser than the nth term. It gives the same number in the modulo operator case. So this is what the difference between division and modulo operators. I hope you understand this. With the idea, you come here. So in this algorithm, we are using modulo operators. So this is what the modulo operator I am using in the algorithm. So I come to the first step. This is the overflow condition. Finally, I'll explain you what is overflow condition, how it works. So before that, I come to the step 2. If front equal to -1 and rear equal to -1, what is it? Suppose front, rear, both are -1 means, what is the condition? The condition is Q, circular Q is empty. If the circular Q is empty, front equal to -1, rear equal to -1 means, immediately we set front, rear equal to 0. Front equal to rear equal to 0. It means that we are reassigning the front position to 0th position, rear position also 0th position, then the control automatically comes to the step 3. So in if condition, it won't execute any else if, directly the control comes here, set Q of rear equal to value. So whatever the value I want to store, the value is stored here in the Q of rear. Why it is given that Q of rear? Through rear only I am executing the enqueue operation. Through front only I am executing the dequeue operation. So even though both the pointer points in the same position, Q of rear only it maintains the value. Okay. So then it saves the value and we exit. This is the first successful execution of the first condition. Okay. Suppose front not equal to -1 or rear not equal to -1 means, this scenario is not executed, it comes to this else if. What is the condition here? Else if rear equal to n minus 1 and front not equal to 0. What is it? The condition? Condition is, suppose rear equal to n minus 1. Rear here, front is not 0. Front also here. Just you think over this. This is the condition. This is the condition. What is the condition? Rear equal to n minus 1. It is there in n minus 1 position. And front not equal to 0. Front it is not equal to 0 because front is there in the second position. In this scenario, what we do, I have to increment the rear pointer to here and store the value. What is that? Rear equal to 0. Then the control comes out. Set q of rear equal to value. What is the value? Value may be some. I am storing value here. So this is the second condition. If it satisfies the second condition, rear it is moved to the, what is that? Front plus 1. Sorry, rear plus 1 equal to, it comes to the 0th position. Suppose this is also not the case, means it is a normal case. In a normal case, what actually the position means, front is here, rear is here. For example, just you take this example. What is the condition? Rear equal to, so what is it? It will not satisfy this one, it comes here. Rear equal to rear plus 1 modulo n. What is rear plus 1? What is the real value? Rear it is 4. 4 plus 1 modulo n. N value is 8. So 4 plus 1 means 5. 5 modulo 8. What is the result? We already know it is 5. So that's why rear is pointed to move to 5th position. Then it comes out. Set q of rear equal to value. What is it? We are storing value here. So one clear? So this is what the actual execution. Now I come to the first step. Okay. So the second step 2 is clear now. So what are all the situations it comes, accordingly we have to do. What is the first condition means? Suppose front is here. Front is here. Rear is here. Front is here and rear is here. Front equal to rear plus 1 modulo n. What is rear? Rear is 7. 7 plus 1 modulo 8 n value. Okay, modulo 8 equal to, what is the value? Equal to front. What is it? 7 plus 1? 8. 8 modulo 8 equal to 0. So we come to 0th position. 0th position already front pointer is there. So that's why the condition satisfies here. This condition is satisfied. If the condition is satisfied, then write overflow. Because already the queue is empty. I want to traverse the rear position into first one. Already it is front is there. So that's why overflow condition, go to step 4. We are exiting because we are unable to execute the Enqueue operation here because of the condition. What is the condition? Condition is a circular queue is full. I hope you understand the logic.